All right, section 10.1. This is a section called goodness of fit, which to me always sounds like some sort of, grammatically incorrect or something. But this is what's going on in here. Okay, on this comes out of the notes. This is if I have like some sort of spinner that I'm playing for some sort of game, and I'm wondering how, if it like falls on one of the choices more often than the others. It should, if it was a spinner that was working properly, it should give, if I do it 160 times, it should give 40 on each one of the options. Okay, so it comes out equally so that like the game is fair and the spinner is fair. And so that's my expected. I plan on doing it 160 times. I do it 160 times, and this is my observed. It didn't happen right. Okay, I got way more of this one than I did of that one. They should have come out equal. So what goodness of fit is testing is it's testing to see if, you wouldn't expect it to come out perfect. The numbers that one might be 39, another one might be 41. But is this this looks really unfair to me. Is that just because of randomness, or is that something that's really important? So this is measuring to see all these numbers, they're far apart from where I expected them to be. Are they so far apart? So it's kind of measuring fluctuation. How far away is that? That's what's going on here. So that's why I'm starting in with this calculation. Observed minus expected. Okay, so 32 minus 40. 38 minus 40. 44 minus 40. 46 minus 40. Then what you do is you square each one of those numbers. Okay, negative times negative is positive. So negative 8 times negative 8 is positive 64. Positive 4. Positive 16. Positive 36. That whole line should be positive. Then it says I'm supposed to take all of those numbers and add them together. All right, so let's see. 64 plus 4 plus 16 plus 36. All right, let's see. Try it again. 64 plus 4 plus 16 plus 36. 120. Okay, and then what it says is I'm supposed to take that number, the 120, and divide by my expected. My expected was 40. And that's sort of a measure of the amount of fluctuation there is. Okay, that the numbers, this whole thing is driven by the fact that these numbers were so far apart, I'm squaring like negative 8, 64. That's putting a lot into this. Well, was 3 a good number? Is 3 a bad number? And to measure whether or not 3 is good or bad is back to that chi-squared chart. So this is like a chi-squared that I have just figured out. I'm calling this one mine because it's the one I did the work for. Then there's chi-squared chart. Okay, so go to the chart. Again, it says degrees of freedom. Check down at the bottom. It says K minus 1 for goodness to fit with K categories. All right, so I do a minus 1 thing again. I got 4 categories, so I go down to 3, and I go over to 0.05 because that's the industry standard. I don't need 2 parts to this like on that last time we had this. We had to take the left-hand side and the right-hand side. I just go down to 0.05 and to 3, 7.815. All right, so I compare mine to the chart. Chi-squared mine is less than chi-squared chart. Well, is that good? Well, this was a measure of fluctuation. Numbers are super big if there's a lot of fluctuation. And this one, my number's not super big, it's 3. Okay, so mine isn't really, as far as this is concerned, the amount of fluctuation is a 3 when you're allowed to get away with 7.8 fluctuation before you even start worrying about it. My fluctuation is smaller than what the chart says I'm allowed to have, so it's not that much fluctuation. So I'm allowed to say that this spinner is fair. That's just a normal thing that could have happened to me, even with a fair spinner, just could have happened by randomness. If it had come out that chi-squared mine was like 15, then it's bigger than what the chart says I'm allowed to get away with. That's a whole lot of fluctuation, and you have to go, no.